Now we will take a look at the mean value theorem. So for the mean value theorem, what the mean value theorem say? So we have f is also a continuous function over the closed interval and differentiable. So these two things must be defined. And the mean theorem will guarantee you that there will always exist at least one c in between the interval such that the derivative of that value will equal to the average rate of change. Okay, so it's gonna equal to the slope. So let me draw the graph for you to visualize. So if I have a continuous function this time, it does not necessary to be have the fa equal fb. It could be a right here and b right here, right? So if I draw a line go to the point A and B, I'm gonna have that line. So this line, if I want to find the slope of this line, isn't that I will have y2 minus y1 over x2 minus x1, and that is just same as, so this line right here, the line is the slope of the line is actually equal to f of b minus f of a over b minus a. So this is the slope of the line, okay? And because this function is a continuous function over the interval a and b, it's also differentiable. So the mean value theorem will guarantee that there will exist at least one c, and I do see a c right here, that have the same slope as the line. Same slope at the line, yes. And this is gonna be the point C right here. If I draw the slope, this slope will have this, this line will have the same slope as the secant line, okay? The derivative line will have the same slope at the secant line. And is that the only C? No, there will be one more somewhere right here. Another C that when I draw the line, it also have the same slope. How do we determine the line is the same slope if they are parallel? As long as the line is parallel, they're gonna have the same slope. So it means the value, when I put the value into the derivative function of f of x, that will be equal to the slope of the secant line. So this is gonna be equal to f prime of c. Okay. Now let's take a look at this example. I want to verify the mean value theorem first. And then one is the mean value theorem applied. Then we're going to find the C that guaranteed by the mean value theorem. So let's check the mean value. So first, I want to get the domain of this. So this is the radical function. When you have an even radical, we need to set all the things that inside the radical greater than 0, right? So this is going to be x greater than or equal to 0. So since f of x have a domain is greater than or equal to 0, that means f of x will be continuous and differentiable from 0 to infinity. So f of x is continuous and differentiable from 0 to infinity, because 0 to infinity, but this is 0 to 3, so we don't have to worry because it's going to be continuous. So we're going to have to say 0 to 3. And so mean value theorem apply will guaranteed there will be a C between this interval such that the instantaneous rate of change is same as the average rate of change. So this is saying that the I rocks is equal to A rocks. Okay, the instantaneous rate of change is equal to the average rate of change. But how do we actually apply to the problem? So first, we're gonna find the average rate of change first. So A rocks will be f of b minus f of a over b minus a, right? And f of b is what? My a is 0, my b is 3. So f of 3 minus f of 0 over 3 minus 0. So what is my f of x? My f of x is square root of x. So it means square root of 3. minus square root of 0 over 3 minus 0. So it means square root of 3 over 3. Okay, so that is my average rate of change. Now we're gonna find the instantaneous rate of change is our derivative. So I rock is the derivative. I rock is f prime of x, which is f prime. In order to write f prime, I'm gonna rewrite this at the power first, so it's easier for to finding the power rule. So we're gonna see that to apply power rule, we bring down the power, which is 1/2, and x to the power 1/2 minus 1. This gives you 1/2 x to the power negative 1/2. And I will bring the power to the denominator just to easier to simplify later on. So I'm gonna have 1 over 2 x to the power 1/2. Now, the mean value theorem will guarantee that A rocks will equal I rocks. So we just set them equal to each other. So we have 2 1 over 2 x to the power 1/2 equal root 3 over 3. And when you see an equation like this, you have a fraction equal another fraction. We simply cross multiple. Of course, the denominator cannot equal 0, right? So we're gonna cross multiple. We have 3 equal square root of 3 times 2 x to the power 1/2. Okay, and then we're gonna divide 2 root 3 on both sides. So on the left-hand side, I have 3 over 2 root 3. And on the right-hand side, I have x to the power 1/2. But our goal is to find x, okay? X is the c value. We want to find x. So how do we find x? We're going to square both sides to get rid of the 1/2. If this is 1/3, then you cube both sides. So this is 1/2. So I'm going to square both sides. And when I square both sides, the right-hand side will become x, and the left-hand side will become 9 over 4 times 3. Simplified it, we're going to have x equal 3 over 4. So the mean value theorem will guarantee that f prime of 3 over 4 will equal to root 3 over 3 for that. Okay, so this is how the mean value theorem applies. All right, let's try another one. So I have the function x squared plus 2x minus 1 on 1 to 5. So we know this is a polynomial function, so it will continuous and differentiable on 1 to 5. So that means f of x will satisfy the mean value theorem. Okay, so the mean value theorem is will apply. It's satisfied. Okay, so when the mean value theorem is satisfied, then we know that there will exist a value that I rocks is equal to A rocks. Okay, so first thing that we're gonna do, we're gonna find A rocks first. A rocks can be found from f of B minus f of C. I mean A over B minus A. So f of b is f of 5. So we find what f of 5 is. We put 5 into the x. So we're going to have 5 squared per 2 times 5 minus 1 is going to be 25 per 10 minus 1 is 34. So f of 5 is 34. And then minus f of a. F of a is f of 1. So it's going to be 1 squared per 2 times 1 minus 1, which is 2. So minus 2. All over what? All over 5 minus 1. So which is 32 over 4. And that will be 8. Okay, so A rocks give us 8. Now we gotta find what the I rocks is. I rock, since we are already learned all the derivatives, so I rock will be the f prime of this. So f prime of x equal to 2x plus 2. So the mean value theorem will guarantee that I rock is equal A rocks. So it's going to be A rocks equal I rocks, or the other way, it doesn't matter. So we're going to have 8 equal 2x plus 2. And solve for that, we're going to have minus 2 on both sides will be 6 equal to x, and that will give you x equal 3. So that is the C value. So 3 is actually between 1 and 5. So f prime of 3 will equal to A. Okay, so that's how the mean value theorem applies.